Hello guys. Okay, so we'll start the session in couple of minutes. So we'll just wait for some other students to join. So probably we'll start around 4 or 5. So in meantime, we'll discuss the today's topic. So today we are going to do a text classification project. So my voice is clear, right? I'm audible, right? Let me share the screen first. Good evening. Just let me know once you are able to see my screen. Okay, so I hope you guys are able to see my screen, right? Okay, that's good. So, so this is the last class for you guys today for NLP, right? So we are going to use the dataset which is the spam dataset. So spam means like if you guys noticed whenever you are using Gmail or something, right? So there is another folder called spam. So most of the promotional or advertisement related mails are directly routing to the spam dataset folder. It is not coming to your inbox. So how that works actually, right? How if someone is sending a mail, how Google is considering those as a spam or a legitimate email, right? So we have collected around 5,574 emails, right? Out of which we already tagged them as a legitimate or a spam email. Fine. And we are going to do a text classification mining project. Okay, so if you, I am just minimize the chat, right? So I think it's start the session almost all the students I can see they are now join the session. So if you have any doubt or something, just raise your hand. So I can just go and see in the chat room. So Shreya is saying unable to hear. Is it for everyone or is just for Shreya? So I think it's just issue with Shreya. Okay, that's fine. Cool. Hmm, just a second. This. Sir, can you just re-log in? Right? Yeah, I think Yanni, you are facing this issue. So I think everyone is able to see my screen as well as hear me. So just log out and re-log in. Okay. Yes, Redmi has raised the hand. So can you guys please log in with your name? It's a bit difficult to get the name Redmi and all right. So what is your doubt? This chat window disturbing guys? Let me know. Otherwise, I will just close this. If it is not disturbing, and if you guys can manage. Okay. So if you guys have any question or doubt, just raise your hand. Okay. So I just minimize the chat window so you can see my screen. So guys, as you everyone is aware, right? So if we are talking about the model building, what we will do? First, we will collect the data, right? The first very big first process is to first understand the business problem statement. Once here we are good with the business problem statement, then what we will do? We will collect the data and we will do our data cleaning. We will prepare the data, right? Data pre-processing part. Then what we will do? Then we will see which model we can use, which algorithm we can build on top of that data, right, with the clean data. And then we will split the data into train and test, and then we build our model on train data, and then for validation we will validate the data on the test data. Once everything looks fine and the model is performance is good, enough to just do it. So and finally we will, once the model is finalized, we will deploy the model, right? I think everyone is aware of this modeling full process, right? Okay, so I'm not putting more time here because I think this is a common thing what we do. Okay, before coming to the today's class, right? So a small quiz for you guys. Can you guys go quickly and give me the answer? Just a second. Okay, what is the answer? Anyone? Not visible. Gokul is saying the screen is not visible. Is it for everyone? Hello. Okay. Okay, guys. I know it's lazy Sunday today, so everyone is maybe in sleep or something, but just be with me and I'm just waiting for your. I am waiting for this quiz answer. Just go through this quiz. So you have created a document term matrix. You have created a DTM of the data, treating every tweet as one document, right? Which of the following is correct in regards to DTM? D. Okay, I think the answer is A and B because it will converting all the words in lowercase will not affect the dimensionality of data. I think it will impact the dimensionality of data because caps SAME is not equal to small SAME, right? So if you convert everything into small lowercase, it will reduce from 2 to 1. Okay, everyone is satisfied. Shall we move on? Yeah, it should be C, third. Okay, so this part we will just directly do. I think we will go in the code itself and then we will start looking into the things. Okay, as like in the first class, I told the important libraries as NLTK, right? And in the last class, we discussed about the wider sentiment analysis and then topic modeling, LDA and all, right? We are not going to use the LDA and sentiment analysis here because that is the unsupervised learning. Today we are talking about a supervised learning. But our main library is NLTK, which is used for the all natural language processing part, right? So just we will import the data. Before that, I just clear it first. So anyone have any doubt, then just raise your hand, okay? some network issue. So just wait, guys. I think there's some network issue from my end. Um, Shreya, can you try to log in through your mobile phone or something? I don't know, like no one apart from you, everyone is able to see my screen and can hear me. So Shreya, can you please just try, otherwise restart your system and just try login. Because apart from you, everyone is able to hear me and can see my screen. Okay, guys. So we just cleared the cell output. Now I am importing the important libraries, like I have to set my working directory. So I am importing OS. We will use some regex function or string manipulation is there. So I am just loading the required libraries. Then NLTK, right? Just let me set my working directory. Now we will load the data and we will see how our data look like. So guys, what we are going to do, we are after loading the data, we are going to do a data cleaning process, right? So just recall the things what we have learned in the first class. So what, as a part of data cleaning, what you guys are expecting me to do? Anyone? Okay, so we will remove the stop words. Apart from stop words, we will remove punctuations, right? Then we will do the tokenizations. Maybe we will remove numbers. Good, very good. Sumedha Saiti, Jitendran Dutt, well done. Apart from that, still so many things are pending. Right. Maybe we will convert, normalize the data, right? So stemming and lamentation will normalize my data, right? So as in our other modeling part, we will do feature selection normalization of data, right? Okay. So now you can see the data. So with the first column, we have label data, right? Label means either it's a mail which is spam or which is not a spam, right? And if you see the mail body text, so it's just read the second one, which is a spam. So in a spam, the text is something like free entry and in a 2 weekly comp to win FA Cup final tickets, right? So if I just not talk about model and all, you can see if something they are talking about money, right? Money related to some prize money, some prize amount or trophies and all. So those some simply it's a spam mail, right? And if something which is not talking about these words will come into as a non-spam emails. So let's look into the data, how much data we have. And so as I said in the beginning, we have around 5,567 email bodies, right? And we have two column. One is the labeled, either it's a spam email or not. Another one is a body text. Fine. So anyone have any doubt about data? No, right? Right? No, no issues data, right? Straightforward data, right? Okay. Okay. So no one talked about the missing value check, right? Maybe some bodies of the text is missing. There is no such body in that. So just we will just quickly look into it. So as such, we don't have any column which is not labeled. So all of the emails body what we have is labeled one, and even the body of the text is not null. So we are good here. So we do not have any kind of a missing value or something. In case if you're missing value, we'll maybe just drop the will drop that particular column. Let's see like what is the distribution of my label in my label data set, right? Okay, so out of 5572 we have around 746 spam, so which is almost 14% of the mails are spam, you can say, and around 86% are non-spam mail. Okay, so now everyone said something, so let's we are doing the same thing. So I am not removing numbers and all, but you guys can also remove numbers and tags and something. So first of all, what we will do, we will remove the punctuation, right? So let's see after removing the punctuation, how my data look like. Good. So if you see my data, right? So the first body text is the original data. Now in the third column is a body text clean. So after removing punctuation, how my data look like? So I have removed all the full stop, comma, dot, right, question mark, greater than, smaller than, colon, semicolon, slashes, brackets. We have removed all those things, and now we have a clean data, right, which is not having any punctuation. Now we'll move to the tokenization. So what is tokenization? Anyone? Why? What is we are doing in tokenization? Guys, unique word will become columns. No, this is not tokenization. They are not converting anything in columns, right? That is vectorization. Yes, Himesh, that is vectorization. Not okay. So Jitendra is said correct thing, separating each word. Fine. Rohan is also saying the same thing, generating a list of word which is unique. Correct. It's not about unique, Rohan. So it will not give you the unique word, but what it will do, it will just split the sentence into words, right? Getting my point, right? Yes, and we will tell them as a smaller one as a tokens. Fine. So it's not about unique words, guys. So if a word is coming two times, it will just separate it two times, right? As it is. Okay. Better let's see how after tokenizing how the data look like. What I'm doing, I am just creating a own function tokenizer where I am passing each and every body text, right? And then I am tokenizing it, right? I have applied for on the full old data set. But what I did here, before tokenizing, I am just converting all the text into lowercase. So if you see, this is my definition. What is definition? It is just splitting the data into words, right? And returning me the words. How I passed it? So I am just adding a new variable called body text tokenize, passing the column which I have to tokenize, and then applying on whole data set. But while applying, I am just passing, converting first them into lowercase, and then I am calling the function. Getting my point, right? So you can see nothing is up in uppercase in our body text tokenized data, right? And if you guys noticed, we have used the data set which we remove the punctuation. Fine. So we are not passing this body text directly. We are using the column which we generated earlier, which is body text clean. Anyone have doubt here? Anyone? Good. So this is our original data. First column is our original data body text. Second is after removing punctuation. Now third is that we tokenize the remove or do we tokenize the clean data. Fine. So you can see here it is just changing into words. So I have been searching comma for comma the right words to, right? Okay. Now still I can see there are so many stop words here, which is of no use, right? In for the right you. Let's let's what you do to just remove all those words. I'm using the stop words from NLTK and using the English dictionary. Okay, good. Now you can see I have removed for the to this. I have removed all those things. Now, why we are doing these things? So we are reducing the dimension of the data, right? So you can say like dimensionality reduction we are doing. Correct? Anyone have doubt here? No doubt. Correct. Good. Now, okay. So, but again, as in the first class I said, why to write three, or maybe you have to add some numbers, remove punctuation numbers, tags and all. You can add those as well. So why we are not writing a single function which can do the all the things? So if you see this code right here, so, okay, again I am downloading the data. So what I did first, I am removing all the punctuations. Sir, ma'am, what is this? I cannot get the audio, sir, ma'am. Okay, can anyone reply to hers? Anyone is getting this issue or not? You guys can hear me, right? Okay. So, so, so I have just whatever the steps we have performed earlier, right? So I use the same thing, but adding everything in a single function, which I named as a clean text. So in the clean text, if you see the definition of my clean text is in the first line, I am passing all the words, whatever they are there in the text, and then I am removing the punctuation. And then after removing the punctuation, I am tokenizing the data. Once I tokenize the data, I am just removing the stop words from the data. It will give me the same result, whatever we saw earlier. Fine. Now even you can see there are some numbers also 2005 87121. So if you have to improve the accuracy on of your model, you guys can do some more cleaning, right? So adds in the same function you can add to remove numbers, you guys can add to remove tags, right? So you can see like it's hands-on for you guys to change this code and do some more data cleaning. Fine. Guys, can someone ping the hers the Zoom ID and password? Anyone can have that handy. Just please ping in the chat box. So hers will maybe join from something. Thanks, Asim. Okay. So now I don't think anyone have any doubt. If you have guys have any doubt, just clear it now itself. Shall we move on, or anyone have any doubt? Guys, I'm going in very slow mode today because we just have to cover this text mining project, and I think we're good to cover by 6 o'clock. So move on, right? Hello. Okay. Now, as a part of just now we discussed. So till now, what we did, we are reducing the dimension of the data. Again, in that we saw we have few words which are maybe in some different word format, right? V1, V2, V3, but having carrying the same information or same meaning, right? Why we are not converting into, why we are not doing a normalization technique to convert them into a base form or a dictionary form, correct? So means why we are going to do the stemming or lamentation, anyone you guys can do, right? So here I have used stemming. You guys can do a lamentation and then see the results, how different results are differing. So I'm using the Potter stemmer from NLTK. Okay, so now just quickly we see some of the examples here. So okay, there are some bad examples also. See, like goes, it become go, right? We are expecting GO, but GOE is coming. So callers, it become caller. That is good, right? So that is the issue humans actually. So sometimes we will have, we will, what it will do, it just, it thought is E, S is a prefix and it's just removed it. Just Loknath, you have any question? You have raised your hand, Loknath. Loknath, you have raised your hand. Any question or will? Okay. Okay. Now we have cleaned our data, right? Now still we don't have the independent variables, right? And what we sort said is we have to convert these words into the independent variables. Means we are going to vectorize the data, right? So I said there are few things like bag of words, like TF-IDF, but TF-IDF is better because it is giving me the weightage of a particular word. Either that is a word is a very rare word or very common word, right? So I am using TF-IDF to vectorizing my data. Fine, guys. Okay, so see, there are so many numbers. So you guys can just add, remove numbers, and then after numbers, see, words are coming, right? So, so many words. Basically, actually, it's a, okay, guys. So you can see down the line we have all the words, right? And even you can see there are so much of numbers coming. So you guys can remove those numbers. Okay, now just see the sample of the data. So I am just taking 20's document, almost 192 words are coming. So this is a small sample of that vectorized data. Okay, now from this vectorized data, we are going to create a sparse matrix, right? And we are just storing the, okay, so see, now our data set looks like this. So this is the vectorized form of our text data, right? Now what we will do, we will use this data to create our model. Okay. So anyone have any issue during the vectorization of our dataset? With the help of TF-IDF, we are vectorizing our dataset. So you can see there are some numbers like 0.231645. So these all are weightage of that particular this word. This word on in document fifth. So this word particular number is coming on fifth document. Okay, so now apart from this, we can also create two or three more features, right? As we discussed in the first class, if we can see like what is the length of a email, right? If it is very big email or something, maybe it's more on a spam side, right? So I am just adding two more variables, which is body length, which is nothing just that is the length of our email text, and another is a punctuation. So what happened generally, you guys have noticed this maybe. So if something is a promotional mail or something, they will put a lot of exclamation sign, at the rate, and all, right? But in a general mail we don't use so much of punctuations, correct? Have you noticed that, guys? Did you anyone notice like in the promotional mails we have a lot of punctuations? See, so now I have added two more columns. One is body length. This is the number of words in my email text and how much percentage of punctuation. You can see the spam, it is labeled and it is coming around 4.7% punctuation, right? But also you can see this is very less, maybe some mail we are putting, right? And due to those emotions, last time we saw, right, in our emotion, if you are sending a mail to my friend or something, I just add so many smileys or exclamation sign and all. Maybe this comes under that category. It has very less word length, 28, but high number of punctuation. So but mostly if the punctuation is more, we will think like it is a spam mail. But let the algorithm decide, right, what is the rule it will create. Okay, so just we are plotting this. We want to see the distribution of our punctuation and body length. So we are just creating the histogram. Okay, so it's look like it's not normally distributed, but we have around a good distribution, right? So it's very skewed, this punctuation marks. Okay, so now till now what we did, we are created, we added some features, we removed, we did the data exploration, and then we cleaned the data. During cleaning we check the meshing value, we have normalized the data using limitation stemming, then we have reduced the dimension of the data using different techniques. So same thing I just put in a single cell, right, where I'm doing the same whatever we discussed till now. Now as now the data set is like a simple data set which is ready to for the modeling techniques for algorithms, right? Fine guys. Okay, so in meantime I just look into the PPT, so we will cover everything or not, we'll just cross verify it. don't know, guys. My system is a bit slow today. Okay, so I have added the same thing. Just we did all these things. We covered these things. Okay, so a small quiz for you guys. Yes, Hers, we can talk on this. I think we have time today. I will tell you some techniques, what I use generally. So, uh, I'm not sure about Flask and whatever you said, the Django. I generally use Azure, I use PowerShell to deploy my models. But whatever I do in my practical life, right, day-to-day life, so I can just share my experience how I do the modeling deployment and all. Okay, guys, I'm waiting for your answer. Yes, you can create a pickle file. You can use import DLL to save your model. Okay, guys, at last we will you talk down this, right? So first, just go through. So we will finish it soon today because I think most of the things you guys, since you guys already have learned algorithms, so it will not take much time. So Anuruddh is saying A, name bias. Okay, Rohan is saying B and C, but there is no answer called B and C. Rohan is either is one to A or B or C or D. Gokul is saying B. Okay. So again, guys, I think you guys have to read the statement first, right? So what a statement say? What kind of learning it is? Is it a supervised learning or a unsupervised learning? Right. Then I think then it's case of unsupervised learning. A, B, C are for the prediction, right? It will give you probability and all. So the answer is D. Okay, C. So you guys get confused, right? That's right. Sometimes you feel the things are very easy, but it's not like that, what we think. Okay, so feature extraction we saw and tries just now we ran, right? I don't want to go into TF-IDF because in the first class we have went through it and in we have discussed all the terms, how to get it along with the example. But that is not the option, hers. So stick to the question, right? So that is the only thing. So you can, I needn't ask what we can use for unsupervised learning. There are, apart from CNN, you can use so many techniques. But the question was tricky because we have given you unsupervised learning and then asking for the answer which are all related to supervised learning. Okay, next question for you guys. Again, just go carefully. So what we do first in case of just now we just saw, right? Okay, one answer is A, D, B, C, 3, 3. So everyone is saying 3. Anyone else other apart from 3? So I think everyone is saying 3. So no one is with 4. So A is common, right? So text cleaning in any case we will do first text cleaning, right? What is gradient descent? Anyone have any idea? What is this? Can anyone tell me? Error cost function. Okay, how what it will help basically? Just tell me what, like how it is helping this what is this gradient descent is basically doing to find local function, local minima you said, right, Anirudh? Local minima or global minima, right? It's not local, even for global we use it. Okay, so the answer is correct. Is first we will do text cleaning, then we will convert text to predictors, and then we will use the modeling, which modeling means we are going to reduce the error term, right, with the help of cost function and gradient descent, and then we will see the model performance is good or not, then we will tune our model. Fine guys, anyone have doubt here for the answer C, sorry, answer 3? Okay, great. Okay, so now no, Himesh, actually in every algorithm we have cost function and we have gradient descent. Even linear, logistic, everywhere is there. So basically cost function is error term function, and gradient descent, what it is doing, it is helping you to is a process which will reduce the cost function. Okay. So modeling, what we did, so this was our original text, what we saw. Now after doing all the data pre-processing part and then converting into vectorizing, we have converted this in like a this one. It's like a numbers forms, right? Then easy. Again, what we are going to do is we will train our model, right? So, so how this train works? Sometimes it's very irritating. Okay. So I train my model and my model is predicting something as a ham, right? Then what we will do, we will again, we since we why we are using the label data, because we want to find the accuracy of our model, right? So if I am predicting something as a ham, and then I will check is it a real ham or is it a spam? If it is a real ham means we are predicting correctly, right? And if it is not a ham, it was a spam, but my model is predicting incorrectly, like misclassified, right? So it will comes as a error part, right? So misclassification rate. So this is the same. So here in the first case, I am predicting ham and the actual label is also ham. So I compared my result with the actual result, and it is coming same. So I can say my model is working fine here in this case. But in the another case, I can see my model is predicting it as a spam, but really it was a ham. So this means I am misclassifying the email, right? Okay, so coding part we will see. Okay, now we will see what is model accuracy. I think you guys are aware of confusion matrix, everyone, right? Not apart from Himesh, anyone else? Okay, okay. So okay, I will come back to that. Okay, now just split the data into 80-20. I am splitting into 80-20 part. Okay, and then I am building a model on top of that. So I am using random forest and gradient boosting. I'm not going to talk about the random forest gradient boosting and all, guys, because this is already a part of your earlier study, right? But what we will do, we will run some several models and we will see which model is giving the best performance, right? So one question here, once we ran all these models, right? We got the confusion matrix. How, which parameter you will like, just now we saw we are getting in confusion metric 4 5 stats like accuracy, precision, recall, f1 score. So in case of a classification model, which you prefer most? Is it accuracy, recall, precision, f1 score? So what is the best stats to look into? Okay, Rohan is saying accuracy. Fine. So many guys said they are good with this confusion matrix, and I'm not getting any reply from others. Rohan, Loknath, Jitendra, Himesh, Hers. Okay, it depends upon what. So this is also again this creating a model and understanding the model is a bit difficult. Okay, I'll compare the output. But if I am just telling hers, you have created just one model. So in that one model, if I'm not running the gradient boosting, I'm just running random forest. So in random forest, what I will look first? Accuracy, I recall, precision, right? Okay, Palas is saying F1 score. Okay. And you know, guys, how we are getting the best threshold, right? Like everything is giving probability, right? And then we are converting that probability into the 0 or 1. So what is the best threshold we will use either in gradient boosting or anyone? How to get that best threshold? So everyone is okay with my question, or I have to again reiterate. So my simple question is, now I have my model ready. Fine. I can see the accuracy is around 97%. Precision is 1. Recall is 0.796. Right. So all the numbers looks good. And what is precision 1 means? Can anyone tell me who is aware of this confusion matrix? What do you mean by precision 1? Guys, just now you guys, everyone said you are very good with confusion matrix. I'm just asking the basic questions. Okay, so Harsh is saying this means that all your positive samples are classified as positive samples and none of the positive samples are classified incorrectly. Fair enough. One by accuracy. Uh, I don't think so, Gauri. It's one by accuracy is the precision. Okay, but what I feel is after that, other answers like out of all actual positive results, how many are correct, right? So this is more look like a recall for me, right? Positive values. First, guys, what is positive values? So I believe one is for spam emails, right? So we are creating this model to detect spam. So if my model prediction is one, it means it's a spam, right? And precision means, so if I have 100 emails, out of 100 emails, we saw we have 85% emails, like 85 emails as ham and 15 are spam. Correct? Guys with me, right? Till now here everything is fine. So out of 100, I am saying 85 as, okay, just let me open Excel. Okay, so this is actual, fine. Ham, spam, okay. So what I am saying, there are 70 ham, 30 spam. Or sorry, in our data is 85 and 15. Fine. And now this is my prediction. And fine, everyone can see my screen, right? Okay. Okay. So now I am saying I have predicted 60 correctly spam. Sorry, ham. Right, right. This is ham and 10 spam. Now can you everyone will tell me what is, so this is my from model. Okay, this is from model. So whatever I predicted from model, out of that 60 was correct ham and 10 was correct spam. Can anyone try about this precision and accuracy and recall? Leave F1 score. F1 score is just a harmonic mean of precision and recall. So yeah, are you getting my question, guys? Anyone have doubt here? This is from my model. Out of whatever model predicted, 60 is correct ham and 10 are correct spam. Okay. So first you have to create, you have to fill these four things and then you have to find the values. So accuracy is easy, right? Okay, good. Accuracy is 60. So guys, what will come in this cell? What is the number will come in this cell? Okay, good. 60. What will come in this cell? 10. Then what about this one? 25. Very good. What about this one? Right. See, Now the confusion matrix is also ready. Now you have to find the accuracy and precision. Fine, fair enough. So other, maybe if someone has doubt how it came these numbers, please let me know so I can explain. Otherwise, I think like everyone is okay with this matrix. Now I need precision and recall. So Sahiti is telling precision as 92. Anyone else? You guys need some time? 1 or 2 minutes? I can give because this is very important for any algorithm. Get the confusion matrix right. It's not like it's text mining thing, right? It's a common understanding of modeling. Okay, so I'm just giving 1 more minute of time because I can't see anyone's reply apart from Saiti. So you guys can try. I need the answer for recall and precision. Okay, I think okay, so numbers are coming. I thought maybe no one is trying. Okay, someone is saying recall equal to 60 divided by 60 plus 25. Okay, see, you guys can see so many answers are coming, right? And when I asked, everyone said they are very good with confusion matrix. Himesh, I don't know is correct or not. Once I will try from mine, you can just check your numbers. I just randomly pick this example, right? I didn't think about this example. I just put that example. I am not aware of the answer as well. Let it be. So, okay, I think then maybe see if you guys are not aware of something, you guys can now ask now itself, right? Out of 51 students, just getting answer from 5 or 6 students. Okay, okay, guys, just wait. Let's see your result when I am going through it. Okay. So what is accuracy? Accuracy is means out of correct spam or correct ham, how many my model is predicted correctly. So the ham was total 85. Out of 85, I have correctly predicted 60. Okay. And out of 15, I am correctly predicting 10. Okay. From total data, like 100. Fine. Good. Accuracy is 70%. So almost 100% students are whoever replied for accuracy all said 70% and you all got 10 out of 10. Now see the recall. Recall says what was the actual number of spam? Which was 15. Out of that, how many you predicted correctly. So out of 15, my model predicted 10 correctly. So 10 divided by 15. So who, I didn't see anyone said this 0.67. Is anyone? So anyone have doubt about recall? Out of 15, okay. Calculate for ham also, not an issue, right? Spam ham out of 85, I have, right? So what is the recall for ham? Anyone? So accuracy is same, 0.7. So we have predicted 60, uh, 60 correctly out of 85, right? So if you said hers about ham, then it will be right. But basically we are creating a model to detect spam. So you have to focus on spam, not on ham, right? Getting my point, Himesh? Okay. Now precision, because I don't think anyone told me about 0.67, right? Now come to precision. Precision, we always talk about the prediction. So recall what we talked, prediction versus actual, correct guys? In precision, we will talk about only about the predictions. So if you see, totally we predicted 35 as a spam, right? Correct? Everyone is with me? Our model is saying 35 as a spam, but out of this 35, this was misclassified, right? This is also misclassified. So out of 25, only 10 was correct. So precision is equal to what was actual correct divided by total number of prediction. See what is the precision. I don't think anyone said 0.28 for precision, right? So everyone's answer is wrong. Fine guys, anyone have any doubt here? Then if anyone's answer is not correct for precision, no one will give the correct answer for F1, because F1 is just a harmonic mean of 2 into this into this divide by this plus this. That is fine, Hers, but if you have this answer incorrect, this will always be incorrect, right? So see, everyone now was telling about they are good with confusion matrix, but none of the answers was correct. That's why after telling you guys, you said you are good with confusion matrix. Still, I want you to tell you how to calculate the confusion matrix. Yeah, that is fine, Hers. So that's why this is name itself is saying confusion. So every time we get confused. But if you just go through the way I told you, right? So now I don't think you will are going to forget the things, right? So recall means predicted versus actual. Fine. Precision means predicted versus predicted only. So out of how many predicted is actual prediction, right? And F1 is just a harmonic mean. Okay guys, I am pretty much done with this confusion matrix again, but still I am asking, if you guys have any doubt, I will just tell you one more time. Anyone? If no one is replying, I think like everyone is now okay with this confusion matrix, and I will move on. Okay. Okay, Hers. Good. Very good. Because see, this is the things you have to understand. Otherwise, typing a code, running a code is quite simple, right? Even I'm not typing, I'm just running the codes. So see, every time when we talk about accuracy, the very first thing how to create this table. So this was my actual. So in my actual data, we have 85 and 15 as labeled ham and spam, right? Now my model prediction, you can say basically, when I predicted, I am predicting the same amount, 100 emails, right? But out of 100, when I predicted ham, the actual ham, when I checked with the actual data, it was only 60, right? That means 25 still I am doing mistake. Same thing I have put here, 60 exact ham, but 25 was, I correctly put that as a spam, but really it was a, in actual these 25 was ham, but when I predicted, my model is saying them as a spam. Okay, so this line done. Now out of this 15, 10 I predicted a spam as a spam, so that's why I put 10 here, and total number was 15. So 5 I misclassified, means out of the 5 spam I am marking them as a ham. So this is my now confusion matrix is ready. Fine, everyone. Now once this confusion matrix is ready, this is green one is saying as exactly correct answer. So my model is saying ham, that is also ham. Okay. My model is saying spam, that is also spam. Okay. So accuracy means add these two green divide by total number of result. So 60 plus 10, 70, right? 70 divided by 100. Accuracy is very simple. Now when we talk about recall value, recall, what we consider, recall means the total we predicted correctly as ham or spam. You can find for both the things, right? Even you can find recall precision for ham also. But since we are focusing on spam, I am talking about spam. So what we are saying here, out of 15, 15 was actual number, right? I am predicting 10 as ham, which is correct. Okay. So I am predicting correctly value 10, but actual was 15 ham. So 0.67. But in case of precision, I won't bother about the actual one. I what will see how many times how many predictions I was saying as a spam. So total 35, but out of that 35, just 10 was correct. So I am taking 35 attempts to predict 10 as correct spam, right? So I'm taking 35 attempts. Out of that 35, only 10 was correct. So this will become precision. So you can see my precision is very low, right? Now you understand why if precision is low, I can say, oh my God, like your model is very bad, man. You unnecessarily you are putting 25 as a spam, which is very bad because your precision is very low. If just think, I am telling, just assume out of 100, I am saying everything 100 as a spam, right? I am telling 100 as a spam. Okay, like just simply think like this is my prediction. Okay, I am saying everything is spam. So in that case, if you see the accuracy, what is accuracy? 100 divided by, sorry, not 100, 15 divided by 100, right? What is recall? Tell me recall here in this case. if I'm saying all the 100 records are spam? No, but you can see with the numbers also you can see hers. Just tell me, if I'm saying my all predictions are spam, what is the recall? No, Anirudh, this is not correct. What I said, in case of recall, how many you predicted correctly? Still, if I'm saying everything is spam, means 15 out of 15 I am predicting correctly, right? Out of 100, only 15 are correct spam, right? So 15 exactly out of 100, I am predicting 15 correctly because everything I am saying is spam, right? So always recall will be 100%. No, 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 Himesh. Total correctly divide by total actual. So total actual also 15 only, right? Right? You guys still confused. So my recall is, sorry, not 100, my mistake. So 100%, I have to put 100%, but I put 100. So my recall is 1. So you can see if you are looking into recall and precision is 15 was correct, but I am taking 100 steps. So my precision is very low. My accuracy is very low, but my recall is very good because I predicted everything as a spam. But this model is not good, right? So we can't just see the recall. If someone is just looking into recall, they will think like this is very good model, 100% good model, right? My recall is 100%. So I am very much, I can predict all the correct predictions, but precision is very bad. Okay. So always you have to look into these two things, and this should be in line, right? So like the famous one, cancer one, right? Type 1, type 2 error. No, in case of classification project, right, Himesh, you don't look for the accuracy. I will give you one more example here. Just think, uh, I am saying everything as a ham, fine, or almost 90 as ham, fine, right? I can predict, right? So in that case, what will be your accuracy? And spam, just think like a spam. So here 0, here 0, right? Here, if you see, accuracies are not 10, just let it be 0. Let's put as a 10 here itself. Okay. If I'm saying everything as a spam, ham, everything as a spam, my accuracy is 90%, but I'm not able to detect a spam here in this case. And what we are creating model to detect a spam, not ham, right? So you can easily detect the ham mail, but you can't detect the spam mail, even though your model accuracy is 90%. Or you can say 100%. You put 85 here, right? And put 15 here. So in this case, accuracy is almost 100%, not 100%, 85%, right? But you are not able to detect a single spam. So what is the use of this model? Tell me, you are accurate. You are saying my model accuracy is 90%, but I am not able to detect a spam mail. Do you think this is a good model? Anirudh, Himesh? Yes. So always in case of classification, just follow these two, precision and recall. Okay. I think I have taken a lot of time for confusion matrix, but still I am not getting the satisfactory answer. That's why I am just telling two, three, four times. Also, I asked one question, how to get the best threshold, right? So you can create a precision recall curve. So what is precision recall curve? It's something like precision recall curve. Okay. So precision recall curve, I'm looking for a good pick threshold curve. Okay. What happened? I just click on one game. Something like this. Okay, so see, this is a F1 precision and recall curve, right? So this red one is a precision and this green one is a recall. You can see if the precision is going up, recall is going down, right? And the intersecting point, this one, where these two curve will intersect, that is the that we consider as a best threshold point, right? So anything p value is greater than this value, you can mark as a spam. Okay. So Loknath, that time I just told the same answer, right? So you can create a precision recall curve, and wherever they are intersecting, right? At p value you can take as a best threshold. Again, it depends. If you are from some industry where they are not focusing on precision, they are more focusing on recall, right? Then in that case, again, it depends upon industry wise also. Okay. This is one thing, the intersect one. Another one is like sometimes the business itself say, okay, that is fine. If I'm getting the recall very less, that is fine. I just need more precision and more precision. That's it. But the best thing is this recall precision curve. Okay. Now I think we'll just look into our result now. So see this, since this data set is very clean, right? So you can see the accuracy is very good, precision is also good. Even recall is not bad, 80%, right? So in this case, I can say I am predicting whatever I am predicting spam, that is spam. Fine. And out of 10 spams, when I am predicting, 8 are real spam. So maybe 2 I misclassified. Okay. Just see if we run another model, gradient boosting. It will take some time. Just wait. In the meantime, guys, see this after this class, I want you to just create your own confusion matrix. Anything, any example, take like this, or just now I gave you one example. You can think about your example and just calculate this precision recall one more time from your end. So it will be like, so in future you will not confuse with it. Okay. Rather than going for true positive, true negative, true negative, true positive, if you do like this is more easier. Taking some time to run. And also, I want you guys to do some more data cleaning, remove numbers and all, and just see that moreover the accuracy is very good. So I maybe recall and all because precision accuracy almost good. So you guys can go for this. Recall is changing or not. Okay, so anyone have any doubt till now? Because it is taking some time. So okay, so after that I just use some grid search, right, to improve the model performance. But you can see the model is already performing well. So I have just added some more validation. So maybe our model performance is better and better. Okay, so in meantime we will discuss about the deployment technique, right? So you can create a pickle file, right, a DLL file, and save the model. What I usually do, so right now, see, every day some new invention is coming, right? So mostly most of the companies are now moving to the cloud computing, right? So Azure and Amazon, right? Mostly I use Azure. So how we deploy in Azure is, so we have a Azure data factory. Even you guys can, if you want, try. It's a free subscription for some 2 GB of data or something, or 1 month. I am not much sure, but you guys can also log in and see the Azure, because the future is coming is like less coding, right? More cloud-based computation is easy to use. You can log in from anywhere. You can do not have to dependent upon so many things, right? So the future is coming. For, so I think if you have to go for some deployment technique, you guys can learn the Azure Data Factory, right? Azure Machine Learning. So there are two ways in that Azure. I am not able to show you here right now, but I can just give you a brief introduction. So in what is Azure Data Factory, it's just like a first scheduling thing, right? Where you can not even, you can just schedule your model. You can fetch the data. If your data is somewhere in some SQL server or something, you can create your jobs which will run, which will fetch the data. And then you deploy your model, right, on the server. And through ADF, you call Azure Machine Learning, where you will train the data, right? You can train the data, you can create a API link. Then whenever you have a new data, you just run the Azure Data Factory pipeline. What it will do, it will first run the data, fetch the data, then it will pass that data to Azure Machine Learning, where which is you since you first what you need to do, you have to create your model, train your model. Once everything is fine, you have to save the model, because rarely we are going to train model every time. So whenever you do a training model, right, maybe that model will use for 2 years, 3 years, until and unless the accuracy and the other performance is not getting down. You're getting my point. So it's not like always we need to train the data and then score. So once we train the data, we can use the same model for maybe 6 months, 1 year, 2 year. Even I have some models which I'm using from 3 to 4 years. It's a long back. I created that. But what you need to do, you need to timely monitor the performance of your model. Now come back to the deployment part. So one thing I said is your machine learning, is your data factory through which you can deploy your model. Once you can create your own model in that Azure machine learning. There are two ways. There is a fully drop down. Even whatever the algorithm you want, every algorithm is there. You have to just type and you have to drop down. You don't have to type any code there. It's all drop down. Other option is you can use your own code and create a training model. Once you create a training model, you have to create a predictive experiment which convert your training data into a API format, right? And whenever you need that new scoring, you have to pass the data from Azure Data Factory. It will call the API, it will see the model object, it will predict, and it will again give the result back to the ADF Data Factory. And from their data factory, either you can put that in a Power BI report or in an Excel, right? Whatever you want, whatever the source you want, the final output. In an Excel, it will also give you in a text file, Excel file. Even in Power BI report, you just fetch that result and just showcase, create some graph in Power BI. It will refresh. So that is the way which in future most of the companies are going to use this Azure Data Factory, or maybe Amazon AWS is there, right? So these two things are why I am telling you guys. You guys are looking for a job and all, right? So you have to be with the latest technology. Another things are just create a pickle file, right? Either you can schedule it through task scheduler in pipeline. Pipeline means you can create a PowerShell script where you will just put your model object in some places, some your local, somewhere in local, and schedule a task. Whenever the time will come, it will run the model and it will give you the output. In that case, you have to create the model pickle file and all, and use that pickle file to predict the result. So one way is Azure, second way is PowerShell, third way is mostly in the industry. The very good thing I will tell you, like sometimes most of the analysis are ad hoc work. So there is no deployment itself. What happened? You create a model, you run model 2-3 months you did, and you just pass the information to the marketing team, campaign team. What is happening? That data they will use to do marketing, and the result will come after only 6 or 5 months or 6 months. The real result will come. So if they think after 6 months the result is good, again they will ask for, can you just run for the latest data and provide us the result? So again it's a loop of 6 months. In that case we don't deploy the models, because it's a one-time activity in 6 months unnecessarily, because if you deploy you have to maintain the model in real world, right? Again maintenance, it will cost, not cost effective, so it's a one-time activity. So these three things I work till now as a part of deployment, right? Apart from that, someone told me some two things I am still not aware of, right? So I can't tell you which is I'm not aware of. That is fine, guys. Anyone have any doubt about deployment? Hers, Simesh, someone asked, right? Yes, that is very good actually, guys. I want you guys to go through this Azure portal. It is free. You can sign in. You can Google Cloud. Yes, Google Cloud. I'm not sure. I don't think Google Cloud has so much analytics ability right now in market. I mostly heard about AWS and Azure, and that is also they are giving you some free subscription, right? So if something is giving that they are giving you free, you can at least try, and it is very good. So that things also, if you learn and you put it in your resume, Azure Data Factory, right? Azure Databricks. Yes, another one is the Databricks. That is basically, it's a bit costly. It's not cost effective to companies. So companies are rarely use Databricks, Azure Databricks. That is also another technique to deploy. There we have a Spark cluster that is mostly used for the big data platform. Okay, guys, our model has also ran. So there are two things actually, hers. Either it's a batch response, right, or web response. So it will give you two links. Either you have to run through batch, like just like as I said, what in my case is happening. Every month I run some model and give this result to the marketing team. So marketing team can, I have some models for churn data set, right? I will not take the client name and all here, but what is happening? Clients are more interested in churn. They don't want to lose any customer, right? What I do, I just predict which customers are going to churn for next 2 months. Another one is, okay, so in that case, what I am just running using the batch means I run on every month end, right? I trigger, I use the batch API, but we have web API as well. Whatever you are asking, this is more related to web API, where there you have to just put your inputs and it will give you the output. Okay, Hers? You can say real time kind of thing, but I am using batch one. So both the options are available. Okay. Santosh, actually, see, Azure is something, Azure is a platform which is not just giving you thing related to data science. It's an overall product actually. Yeah, so it's an overall product, Santosh. It's not just for data science. So what I said is AML and ADF, right? Using these two, you can deploy your model. But if you are not from the data science background, you can have a lot of other options as well to explore there. So there is no such kind of prior experience required. But maybe first time, any case, in learning, if you do something first time, there is always a difficulty, right? So don't think like this is because that you have to learn the product. You don't have to learn the coding script or some like data science technique there. You have to learn the product itself, right? So I am focusing on you guys to learn the product, not focus on the where to write code, where to write the script and all. First learn the product, then you can easily know how to deploy your model, where to deploy your model, where to write your code, Python code anywhere, right? Okay, now if you see, the gradient boosting is giving me more recall, right? If you see, now from 70 recall increased to 80. So my precision is going down 90. In the first case, the precision was almost 1, right? As I said, if the precision, if you just uh, decrease the precision, your recall will increase. We saw also in the graph, right? Okay, okay, so uh, so these are the something where I am just using grid search and all to improve my accuracy. So I don't think this is giving you more. So at the end, we are already getting some good accuracy and recall. So even these things are not required. So holdout test and grid search are not such that, but you can use for some other. Maybe you can try some other data set, right? So you can also try the Amazon data set, right? What we discussed in the first class. You can create a model on top of that, the feedbacks. There also we have the label data, right? So you guys can create two projects here. One is already discussed. One you can take the, so that's why I just added that Amazon dataset when I was creating this PPT and all, this full curriculum. I have added 2, 3, 4 different dataset. So you guys have can explore from your end as well. again, even if you see the grid search and all, you are not getting that. So accuracy is increasing 0.8, 0.9. So almost we got accuracy of 97%, right? So it will come around that only. So 97.5. So what happened, guys? If you have already a good model, this tuning will also not help much. This is already giving the same. So precision, recall, accuracy, it increased the accuracy recall here, right? Zero point 0.7 to zero point 0.8, right? So another thing, same. I use some linear regression also down the line. Sorry, linear. I'm telling logistic regression also. So this is another concept called pipeline. So anyone is aware of the pipeline concept? Okay, this is not much related to the text mining, but this is more related to the process wise. Yeah, so what is happening if you have a pipeline, you have to just pass the, like, see, so in every time if you don't want to code, right, same process again and again, you can create a pipeline, right? And in pipeline you are passing the things dynamically from above. Like I want, if I am just passing some 10 20 columns, right, down the line I have to split the things, I have to do the same process for any model irrespective of the what is the main data and all. So you can create a pipeline where you have to just do some initial things and then pass it to the pipeline, so you don't have to touch the below codes. Getting my point, right? So I have added that code also, pipeline code, right? So see, this is the pipeline. You can see inside this we are not passing anything. So we are creating a pipeline. Inside pipeline we are saying to use tf-idf, use stop words, and linear, use this algorithm linear svc, right? And what we are doing down the line, we are just passing this pipeline into our train and test, right? So you can use this pipeline for any kind of modeling. What it will do, it will take this, it will fit on x train and y train. Every time what it will do, it will vectorize the data, it will stop, remove a stop words, it will vectorize the data using tf-idf, also it will remove a stop words, and then it will use this linear svc algorithm. Only see, here I'm not passing anything which is related to data and all, right? So this we call pipeline. Okay, similar pipeline I have created for some other. So two things I use here. One pipeline is for multinomial naive Bayes. Another one is linear SVC. Correct, correct, Has. See, here you can see, I can see easily, we can see ham for ham, precision recall for spam. So it is giving you for both ham and spam, precision and recall. Correct? So accuracy is same in both the cases, right? So it is accuracy is just 0.98. So this is the pipeline. Okay, I think guys, I am pretty much done for this today's class. So at do you guys have any question or something which we can just take in the last 10 to 15 minutes? Nina has raised hand. So Nina, what is your question? Nina, you have raised hand. Do you have any question? Uh, this is again, means it depends upon the person and person, right? Person and mostly the job description, so many things, right? Mm, mostly what they will say, like mostly people what they start like what kind of projects you worked upon. Once you say the classification project, they will say, can you please describe me your best project till now you worked, or what is the last project you worked upon. When you start explaining your project, then the concept will come. No one is more focusing on, like, if you have some experience, not fresher, they won't focus much on coding part, right? Mostly the concept part. Maybe for fresher or something, if there is some kind of hands-on session, some nowadays companies are taking, or either it's on they will call you at their center, or maybe online also they are taking nowadays. So apart from that, they mostly look for the concepts, right? Like I said, confusion matrix and all. So if you are clear with the concept, it's pretty easy to clear the interviews. Like I said, Satak, right? So we are doing some hypertuning. We are doing the grid search, right? CV, and we also, if you see, we have added some number of trees and all to do hypertuning. So somehow it will improve your model performance. Apart from that, you see, whereas we have so many variables which are numbers, right? So I didn't remove the numbers, but right now I'm feeling like I can remove those numbers. But since we am getting the good accuracy after that also, so in this case, I am fine if I'm not removing that, but it's better if you remove all numbers, tags, and all from your data set. Clean your data as much as possible, right? So better input, better output. Also, I have added whatever I just told you guys about accuracy, precision, and recall. I have added that in the PPT. So if you have any doubt, you can go to that PPT. So okay, so this thing is pending. So maybe this somehow it looks funny, but this picture is easy to remember. That's why I put this picture. What is type 1 error and type 2 error, right? Type 1 error is telling a male is a pregnant, right? Means it's a false positive. It will never be happen, right? And in type 2 error, so are you guys about aware of this type 1 and type 2 error? So what is this type 1, type 2 error? Okay, so Harsh, now you can see type 1 error is, right? So we have created a model to predict a person is pregnant or not. Fine. With the help of symptoms, I am telling a person is a pregnant or not. But everyone knows, right? So if he's saying this is a male which is pregnant, it never be happen, right? So this is a false positive. Means my model is predicting incorrectly, right? So what is type 1 error is? It is giving the false positive, right? In the second case, a lady is pregnant, but my model is saying she is not pregnant, right? So what is happening? Even though she is pregnant, but our model is saying she's not pregnant. So this is a type 2 error, false negative. So there is always debate which error is more important, type 1 and type 2 error. See, in case if a lady is pregnant and we are saying she is not pregnant and we are not giving her medication or something, right? So maybe there is a chance her health go down, right? And maybe some complication will come. So this, in this case, this type 2 error is much dangerous than that type 1 error, right? Maybe, uh, are you getting my point right here? So why I put this pick is somehow when I am putting this, I thought maybe it's good or not, but now you can easily remember this pick every time if someone is asking about type 1 and type 2 error, right? You can easily remember this pick. It is very understandable, right? Easily understandable. You can't have to think, have to so much think about what is type 1, what was that, false positive, false negative, right? That's why I put this pick here. So now you are aware of what is type 1, type 2 error. So in case of spam, what is type 2 error? So in case of spam, what is type 2 error? Hers? Sneha, Ashish, Himesh. Okay, so Anirudh and Jitendra both are contradicting. Correct. So spam is considered as ham, right? And type 1 error is? Okay, so I think so now you guys are aware of type 1, type 2 error as well, right? Okay, guys, I am pretty much done for today. Any doubt, last 10 minutes? Asking again and again, but I can't see any questions from your end. So in that case, I will just end the session. Happy weekend to everyone. Are we good to close the session? Thanks, Himesh. Okay, so enjoy your weekend, at least a weekend evening. I know it's a bit difficult to take classes on Sunday, but everyone is at home. Stay safe. Okay, guys, I'm ending the session. Same to everyone. Okay, bye.